here's going to be the kicker. This is where your hemoglobin count is important. Your hemoglobin. If your hemoglobin, Brittany and Aubrey, if your hemoglobin count is low, you might be like this all the time.
Therefore,
and you be, I don't feel like going anywhere, I'm tired. Because if your hemoglobin, and so the hemoglobin count, what about a person who's anemic? Any of you ever had an anemic issue? All right, if you were anemic, did you find yourself being tired?
Yes.
One of the key things about anemia is being tired. Hemoglobin count is low. Hemoglobin count is low. If hemoglobin count is low, there ain't enough oxygen delivered to tissues. All right, and so right here, when 0.5 mLs of O2 has dissolved in 100, now keep that in mind, 100, the PO2 of blood equals the PO2 in the alveoli. When 0.5, now look, follow this. All right, now watch. When 0.5, but now cells don't need 0.5. Look at this. Cells need 20 mLs of O2. Cells need 20 mLs of O2 per 100 mLs of blood. Now here's where it comes in. Now follow. With your cell phone, multiply. Get to your thing. 1 gram of hemoglobin. 1 gram of hemoglobin carries 1.34 mLs of oxygen. So if my hemoglobin is 15 grams of hemoglobin per 100 mLs. 1 gram carries 1.34. Is that over 20? A little bit over 20 point something. Now, if I'm anemic, say this. Say, okay, he said my hemoglobin was 12. All right, Aubrey, multiply 12 times 1.34. 16. I'm tired all the time. I don't feel good. I'm just too damn tired. Y'all go ahead and go out and eat. I'll stay here and eat a sandwich. Okay, I'm tired. Okay.
not even hungry.
Not even hungry. Okay, so your hemoglobin is low. Hemoglobin, all right, now watch this, everybody. Cells need. Therefore, most O2, most oxygen leaves the plasma and combines with hemoglobin. All right, now right here. And combines with hemoglobin of the RBCs. RBC, of course, is red blood cell. Red blood cell. Now, in this classroom, y'all don't have, and I don't worry about this. You're healthy. None of you have an issue. None of you have an issue. You're good. But you're going into the health profession, you'll run into situations. You'll definitely run into it. You'll see it. Yeah, you'll see. It'll be there. It'll be out there. But in here, we don't, we're fine. We're good. We don't worry about it. Okay? And so right here, this is just kind of showing you 1 gram of hemoglobin carried, you got to remember this. This will be on the final.
Okay.
That will just bring right here. I'll bleed on it.
Right. Will it be on this test or the final?
Well, it might be on both. It'll be on this one. Yeah, that's right. We got the respiratory test coming up. Of course, the final will have 20 questions over old things. But this will be more on this test, I'm sorry, on the one coming up. All right, 1 gram of hemoglobin carries on the average is 15 grams of hemoglobin per 100. Therefore, 1.34 milliliters per gram times 15 grams, 20.1 or so mLs of oxygen per 100, and that satisfies the tissue. Now, listen carefully. All right, okay. Now, right here, now look. All right, you know this right here. You know this. I know it's dark over here, but maybe you can see it. You know this term, HYPOXIA, hypoxia.
Oh, okay. It's the same.
What is hypoxia?
Right.
Low oxygen. Low oxygen. Hypoxia. And then, of course, right here, you know this term. ANOXIA. No oxygen. Anoxia, hypoxia. Okay, you know those terms right there. Okay, so right here, and so then everybody, the rest of it, attached oxygen is no longer a free gas. Attached O2 is no longer a free gas. Okay? Therefore, it doesn't affect the partial pressure. And attached to what? Attached to hemoglobin. HB, hemoglobin. Your hemoglobin, and I think all you girls that even had a baby, your hemoglobin, everything's all right, right? Okay? Okay. So, I think everybody in this, as far as this is concerned, everybody's okay. All right, so right here, now look, PO2 is the most important factor that determines how much oxygen combines with hemoglobin. Hb plus O2 is HbO2. Now, what is another word for HbO2? What's it called? Remember? Oxyhemoglobin. 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 That is HbO2. Hb, hemoglobin, as I wrote on the board for you earlier, hemoglobin combining with oxygen, HbO2. HbO2. Yeah. Yeah. So there's the deal right there. There it is. And it just pisses me off to no end that I pardon that word, but I can't do anything about the fact that I can't improve the condition of my small airways. And I love my mother to death.
Yeah.
But I grew up around secondhand smoke, and it permanently affected me. It permanently affected me. I've had all the doctors. I asked all the doctors. I quizzed the doctors. Oh, yeah. I talk to them because I teach this stuff. I talk to them. And, I exercise. I do aerobic conditioning, weightlifting, and get my heart rate up. But I cannot improve small airways. And I literally will walk around somebody smoking. I was doing some walking and running. There was a nice-looking young lady on the sidewalk there, smoking a cigarette. And I walked by her and said, "Hey, you're too pretty to be doing that." She just kind of looked at me and I kept walking. I said, "That's sure a bad habit you got." I was ready to run. I thought she might throw something at me. She didn't. All right. Okay. All right. But right here, everybody. Right here. Now look. When blood reaches to... Okay. Now this right here, this has to do with pressure changes. When blood reaches tissues, three factors cause or facilitate the splitting of oxygen from the hemoglobin. Or what makes the hemoglobin, quote, give it up? Give up what? The oxygen. What makes the hemoglobin do it? When the oxyhemoglobin gets to tissues. All right, right here. First of all, low O2. Oxygen separates from hemoglobin and moves into the tissue. When it gets in an area, what area? In the tissues. When it gets in the tissues where the oxygen is lower, then the hemoglobin gives it up. It gives up what? The oxygen to the tissues, to the cells. Why is the oxygen important for the cells? Because cell respiration. Obviously. Cell respiration. All right, another one. Acidity. HbO2, and I'll explain this to y'all. HbO2, see, we have this. CO2 plus H2O yields H2CO3, and inside the red blood cell, it splits into H plus HCO3 negative. This happens inside the red blood cell, which we'll get to in a minute. What is that, Penny? What is that right there? What is it? Hydrogen ion. What will hydrogen ions do to acidity? Will it go up or down? More acid or more basic?
Basic.
More acid, right? More acid. More acid. These things make it more acid. So at the tissue level, HbO splits when placed in an acid. It's more acid at the tissue level. Why? And we're going to get to that in a few minutes again. But at the tissue level, it's more acid. Okay? Now, right here, when placed in an acid solution, CO2 plus H2CO3, H2CO3, and and Roman, and you've had a little chemistry. Y'all, this everybody is a weak acid. It's referred to in chemistry. It is a weak acid. H2CO3, carbonic, that is carbonic acid. It's a weak acid. Now, you two that have had chemistry, this right here, that is a strong acid. That is a strong acid. This is a strong acid. Nitric acid. Another strong acid. Acid. But this one right here is a weak acid, everybody. In that acid environment, what makes the acid environment? Cell respiration. The waste products of cell respiration. As they combine. Now they don't stay, it doesn't stay like that long, because in the blood cell, this will happen, and I'll explain that to you when we talk about carbon dioxide transport in just a minute. We're not ready for that yet, so we'll get to it. All right, so there we have that. Lactic acid, okay, another thing, y'all, that contributes lactic. Okay, I'm exercising. I'm doing it. All right. So what's happening? Lactic acid. Lactic acid is building up as a waste product from muscle contraction. Lactic acid buildup. Lactic acid. Okay? Now, even when you do this, there's a little bit of lactic acid. You don't have to be exercising. You're walking. There's some lactic. Your muscles are contracting. There's some lactic acid. Yeah, this affects the pH a little bit. So lactic acid from muscles contributes to acidity. Contributes to acidity. And then, everybody, right here, the Bohr effect. And an acid, this is BOHR. That's a physicist. Neil, you guys have heard it. You heard this when I mentioned this name? Do you vaguely remember this name? Niels, N-I-E-L-S, Niels Bohr, B-O-H-R. You remember vaguely? Niels Bohr. You remember that? Vaguely? The Bohr effect? The Bohr effect, in an acid environment, oxygen splits more readily from hemoglobin. H plus alters the structure of hemoglobin and decreases its oxygen carrying capacity. You don't need to remember that. But anyway, you don't have to remember that at all. But anyway, in an acid environment, oxygen splits more rapidly from hemoglobin. So acidity, low oxygen, acidity, and then I have another thing, temperature, metabolic activity at the tissue level. The temperature, increasing the temperature, I'm moving around. Increasing the temperature results in heat. This causes blood to give up O2. That's oxygen. Okay, that's it. That's it on oxygen. That's it on oxygen. Now, are you going to have to repeat all that stuff? No. No. You won't have to repeat it all, but that just kind of tells you when we breathe, oxygen attaches to hemoglobin, it goes to the tissue. What makes the hemoglobin give it up? Acidity for one thing. Low oxygen for another. Well, it's up there. You just wrote it. It's up there. You got it, don't you? It makes it give it up. Makes it give up what? Oxygen at the tissue level. We got to have oxygen. We have to have oxygen. Oh, yeah. Oh, man. Yeah. And so those are just some things. Without oxygen, you and I don't exist. Without oxygen, we don't make it. We die. Carbon monoxide poisoning, etc., etc. You know, Holocaust. Over how many Jews were murdered? Women and children. Over how many were murdered by the Nazis?
6 million?
Over 6 million. Over 6 million murdered. Some of them were just shot. You know, all ages. Some of them were put in the Holocaust, in the camps. Bergen-Belsen, Doc Howe. One of my boys was, they went to Carpenter Elementary and Bonnet Junior High School. You know where Bonnet is?
Still there.
Bonnet, and then one went to, then they went to, of course, Deer Park High School. But they went on, Greg, the oldest one, they had an opportunity to go to Europe with a school group way back there when he was at Bonnet Junior High. And one of the things he did, he'll never forget, when he was in Europe, in Germany, he went to Doc Howe. Doc Howe, was one of the prison camps for the Jews, where he actually saw the gas chambers. That made an impression on him as a junior high school. They called it junior high, not middle school back in those days. Junior high made an impression on him to see the gas chambers where the Nazis, you know, killed a large number of Jews in the Holocaust, and so forth. Okay. All right, but anyway, everybody, carbon dioxide transport. Carbon dioxide is carried in several different ways. This is what you have the sheet with. You have the sheet on this. Does everybody have that? Okay, you've got the sheet, and because, and so you're going to be, I'll be writing some stuff on the board, but I've got my sheet right here also. And now everybody has this. You need it, and I will explain how this works. I will explain this little symbol up here, how this goes on. Don't let it blow your mind. Don't let it blow your mind. Is your mind blown?
Yeah.
All right, your mind blown? Okay. All right, right here. Do you have it? Does everybody have it?
Yes,
Make sure, I've
sir.
got plenty of them now. If you don't have this, you don't have it? Okay, I thought I gave you one more ago. I didn't give you one more ago? I've got another one. You need one? Okay, pass it back. All right? Hey, wait a minute. Wait a minute.